Sorry, can you hear me?
Yes, we hear you. Please, can you summarize it in 7 minutes?
Okay. I can't hear you very clear, but I hope you can hear me. Okay. Yes. Okay. Hello, everyone. My name is Behnam Rafie. I'm very glad to be with you. I will present this study on behalf of Professor Dr. Khaled Marar and Associate Professor Dr. Tulin Akçaoğlu. I will briefly introduce sulfur concrete and the literature review we have and experimental program and result and discussion and conclusion. In introduction, as you know, sulfur concrete contains mainly sulfur and aggregates, but to improve its properties, we need to add modifier. So in this kind of concrete, instead of Portland cement and water, we will just have sulfur. So cost-wise, it's very cheap because sulfur is very abundant, and we can provide sulfur from byproduct of gas company, petroleum companies. So, and this is a new material, and this is a new composite to use. Elemental sulfur concrete suffers from unstable molecular structure in long term. So, as I said, we need to add some modifiers to improve its properties. So, for long-term reliability, we need to add some modifiers such as olefin, polysulfide, and these things. In our study, initially, I couldn't find any proper mixer for these kind of studies. So we initially started to design and manufacture our own mixer like this. This mixer has 2 reservoirs, and the inside inside we mix our material, and initially we heat the oil inside up to 150 centigrade, and then add sulfur to melt it. Then we will, in this study, we used high density polyethylene and linear low density polyethylene to modify our concrete. So we used sulfur aggregates and these 2 modifiers. I should also add that we preheated our aggregates up to 180 centigrade in order to save our time to heating the aggregates inside the mixer. As a result, we did FTR test to see if we can modify high density polyethylene and linear low density polyethylene by using these 2 modifiers or not. The results show that we couldn't modify the sulfur structure, but we can improve the properties of sulfur concrete. But at least FTR tests confirmed that the sulfur is not decomposed. In compressive strength and UPV test, we found that our control sample or specimen, we got 20 megapascal in 3 days, and adding 5% of modifiers, each modifier, high density polyethylene and linear low density polyethylene, we increased the compressive strength, and by adding 10%, it's almost the same, but adding more than this amount, we didn't have any improvement because during the mixing, we may have some balling problems by adding more polymers. And during the mixing, we may have some problems like balling problems. UPV test also confirms that adding 5 and 10% also the velocity of the pulses are increased, and it's obvious. In flexural strengths and deflection, adding 5 and 10% increased the flexural strengths. However, adding 15 and 20% of modifiers make our samples or specimens more ductile. So as you see, the modifiers, the polymers here acts like fiber inside the sulfur. And here you can see after flexural test, you can see the stretch of the polymer inside the sample. So this is the good result to increase the flexibility of the sample and specimens. As a conclusion, based on FTIR test results, it was determined that the sulfur is not decomposed. However, no chemical reaction between polymers and sulfur. It's revealed that by the UPV test that specimen with the lowest percentage of polymers are denser and more homogeneous than those with higher levels. And compared to the control sulfur concrete with no modification, the concrete with 5 and 10% of each polymer exhibited improved compressive and flexural strengths. And this is my references in literature review. If you have any question, I tried to keep very short because I had just 10 minutes. I didn't know that I can continue for 1 hour, sorry. If you have any question, I can answer your questions.